In the previous video, we have created some logic that will drive our shooting mechanic. So now currently we are able to click and we are printing those debug.log statements at some interval depending on the setting that we have in our weapon data in our scriptable object for the weapon delay. And of course, you can play around with those settings. So for example, we can set delay to be something like 1 and we can try pressing, and we can see that our debug.log statements are printed about 1 second apart. And we can clear it, and let's set the multi-bullet shot, and let's set the bullet to be 5. Let's try shooting now. You can see that 1, 2, 3, 4, 5 debug.log statements were printed. Now do mind that if you are changing the data inside our scriptable object, you are changing it permanently. So if you stop playing, it will still be as it was. So let's reset the bullet count to be 1, the multi-bullet shot, let's uncheck it, and let's set the weapon delay to be 0.1, I think it was. What I would like to do now is I would like to start creating the bullet prefab so we can actually shoot something from our gun before we go any further, so that we have some visual feedback. So let's do that in this video. Again, we should head to the _sprites folder to see what we have for our bullets. And I believe the bullet sprites and all the explosions are in the FX pack. And you can see that we have different bullets here. And we have some explosions, impact effects. Those are from the Superpowers GitHub asset pack that I have linked in the setup project video. But I have also this big tile map of bullets. And here are multiple of the bullets that we can use. And we can actually, it's better to just open it up in the sprite editor. And I think we are going to go with those yellow bullets top center of the screen. Of course, you can choose any other bullets or implement any other bullets. The important part is that it is great if the bullet has an animation, even a simple one. So we are going to use those sprites. I'm going to close the sprite editor, not editing anything else. So I think it is about 56. Yep, 56, 7, 8, 9, and that's it. So this will be our animation of the bullet. Okay, and one more important thing is that if we drag our bullet here and change the sprite render from the sorting layer default to the foreground, you can see that our bullet is pretty big. Now, this is one of the more important aspects of 2D games. First of all, the bullet should be bigger than the real bullet is, and this is because for once we can implement some boss fights, and one of the tasks can be that the bullet flies really slow and you can avoid it, but there are multiple bullets flying all around you, so this is one of the challenge of the game. And another one is just for sheer joy of looking at it and animating it and seeing those big projectiles hitting the monsters. It looks much better than what we would have if we have used those small bullets that would fit such a gun. We can create a separate layer for our bullets so that our light doesn't affect them, so they will not get darker, but instead they will be on its own sorting layer and they will go on top of any object. Okay, since we have already dragged the sprite, let's maybe create a game object out of it. So let's F2 to modify the name of this, and let's call it bullet. Great. Now, since we have couple of frames for this bullet, let's add to our bullet game object an animator. Okay, and to use it, we will need to create an animator controller. So let's go to our _animations in the project section. Let's right click, create, and let's choose the animator controller. Let's call it bullet animator. Great. Now what we are going to do is assign it to our bullet game object. So choose the bullet from the hierarchy and assign the bullet animator. Okay. And now what we can do is simply select our bullet, open up the animations window, or you can choose window, animations, and choose the animation. And we can simply create our animation. So let's click it. We are going to go into our _animations to the others, and let's name it bullet fly animation. Okay, great. Let's save it in our other folder. And we have our animation. So let's go back to our underscore sprites folder, open up our FX, and choose the M484 sprite. We're going to look for the index 56. Okay, and we have 56, 7, 8, 9. So we are going to select those using Shift, and we are going to drag them into our animator, into our animations window. Okay, we can select all of those and drag them around. We cannot really apply a very long stretch of time for it to work, so let's play this. And it will only animate once, it will get to the biggest size, and it will stay this size. So let's see if it isn't too slow. Maybe we will decrease the time that it takes, and I think it is around 10. So let's play it. Okay, I think this is good. So this will be our animation. And if you go to our animator, again, you can open up it from the window. It will become, if we select our bullet, it will become its default animation. So what we want to do is to make sure that it doesn't loop. Let's go to our animations folder, to the others where we have created our bullet fly animation, and let's uncheck the loop time. So it will always become from the smallest sprite to the biggest sprite, and it will stay at that sprite until it collides with something and it's destroyed. Okay, let's go back to our scene view and to the game view. And what we will want to do to our bullet, so let's select it in the hierarchy, we want it to have a collider. So maybe let's reopen the animations window, because it will be important in terms of the size of our bullet. So the smallest bullet is, the smallest sprite is this, and it grows forward. So we will need to select, for example, this second or third, I think second bullet, and let's assume that this will be the size of our collider. So selecting this frame, let's select our bullet, and let's add to our bullet a component, and let's type capsule collider, and we should have capsule collider 2D. Let's add it, and we can see in our scene view that this is just a circle, and we do not want that. So what we are going to do is make sure that we are setting this direction in the capsule collider 2D component to be horizontal, and now it fits much better our game object. If it doesn't, you can manipulate the size of it and the offset. Let's see in our animations. So our small bullet will have too big collider, but it will quickly gain the size, and our bigger bullet will not hit until it flies towards our enemy or towards our target. So what we can do is we can make sure that we move our collider a bit. So let's choose the offset on X. Let's move it a bit forward. I have 56 here, and it should be good enough. Yes, I believe so. Of course, we may change it if it doesn't work for our purposes, but I think it is good enough. Well, maybe we could decrease the size on Y value to make it a little bit thinner. Okay. Yeah, I think that's good enough. Okay, so this would be our bullet prefab. Now, first, we do not want it to be lit by our lights. So let's go to our layers, or we can go to the top right corner, and we can select this drop-down list near the account and near the layout. And let's choose it, and let's choose edit layers. Great. We're going to add a layer called bullets. And let's apply our layer to the bullet sprite render. So let's choose this bullet in the hierarchy, and let's apply to this additional setting sorting layer as bullet. Okay, and we can see that this isn't affected by lights because we have created it after setting up the lights. So this is quite important, because if you create another layer, you will need to tweak all the lights, and that's mainly because that's mainly why we have created this torch prefab, so we can tweak everything in one place. And one last thing that I would like to add to our bullet before we make it into a prefab. I don't know why animator is disabled. Let's enable it. I would like to add to it a rigid body. So we can minimize the sprite render because we are not going to use it. Animator and capsule collider. Let's add to it a rigid body. And we should have rigid body 2D. Now, since this will fly in the direction that we want it to fly, and it should not move our enemies or player, it should only signal that we have collided with it, we are going to change the body type to be kinematic. And this means that it will not move anything when it hits it. It will only signal us that on collision event has occurred. And this is perfect for us because we are going to check if we are colliding with something and take appropriate action inside a custom script that we will create for this bullet. And make sure that you freeze the rotation just in case, and everything should be good. Well, we could change the modes here depending if our bullet doesn't work, if our enemies are not hit. We may want to change the sleep to never sleep and to interpolate, for example, so that we tweak our settings for the physics engine if we have some issues with our bullets. We will see about it in the future, but for now let's leave those settings as the default values. In the next video we will create a separate script for our bullet prefab, and we are going to check out the collision matrix in our project settings, and I'm going to talk a bit about it so we can understand how the collision can occur. So let's drag our bullet into our prefabs folder just so that we have it saved. Okay, see you in the next video. In the previous video, we have created a bullet and added some sprite render and animator capsule collider rigid body to it, and we have dragged it into our prefabs folder to make it into a prefab so we can reuse it in our project. Now, I have said in the previous video that we are going to talk a bit about how the collision works. Well, the collisions work using the collider, of course, and the rigid body, but to detect a collision, or rather to detect what we have collided, we are using the layers, and not the sorting layers, but the layers that are the physics layers, and we can use tags. So what we can do is either we can make our object be on a specific layer, for example bullet, and then set in the top menu we can open up the edit and choose the project settings, choose the physics 2D, and in this layer collision matrix we can say with which layers should this particular layer collide. And this is pretty important because the collision detection will only check against those objects on those layers, instead of checking every possible object for collisions. So the limit of it is that if you go to the top right corner of Unity, open the layers and edit layers, and select the layers, we have only 31 layers. So we might want to only reserve those for very important collision detection systems, while checking against what is the tag of an object, which is a bit slower, but still we can do that. So make sure you have this menu open, so top right corner, layers, edit layers. Open up the layers, and we are going to add a couple of layers. First of all, we will have a layer called bullets. Okay. Next, let's create a player layer. Next one will be enemy. Okay. We will also need obstacle if we want to detect the obstacles. Okay. And let's create two additional ones. One will be enemy collider, and the second one will be player movement collider. And the enemy collider will also be enemy movement collider. Great. So now we have created a couple of layers. Let's go back to the top menu. Let's open up the edit and project settings. And you can see, I'm going to maximize this window, that in Physics 2D we have those layers added into our Physics 2D collision matrix. Now this will allow us to make sure that the collision occur in a way that we want them to occur. So for example, we don't want our bullet layer, here it is, to collide with itself. So we do not want the bullets to collide with themselves, but we want the bullets to collide with our enemy and our player. And for example, our movement colliders will not collide with anything else. So let's uncheck all of those collisions for our movement colliders for the player and the enemy. Because, for example, I do not want our player to be pushed by the enemies, but instead I want to make sure that our enemy movement collider collides with other enemy movement colliders. So let's close this window. And if we go to our player, currently we only have this movement collider. And we want to set this movement collider game object to be on the layer player movement collider. And in this case, this player movement collider will be able to collide with obstacles, but not with enemies who will also have such movement colliders. But we are going to leave the collisions on so that enemies that we will implement very soon will collide with each other. Okay, so last thing that I want to do is I want to set our player. Let's select the player from the hierarchy. Let's set the layer in the inspector to be on the player layer, and let's say no to this object only in the change layer window. So this all this says is, do you want to change the layers for every child of this object? And I do not want to set it, because I'm going to add a collider to our player that will collide with bullets, but not with the movement colliders. So this is the power of layers. We are going to explore it more when we go into shooting and the enemies attacking us. So one last thing that I want to do is make sure that the bullet is set to be on the layer, the bullet layer, and make sure that you click override, and you can see that we have overridden the layer. So let's apply it all, and we have all the bullets, all the prefabs will now be on the layer called bullets. Now, before we can implement a script for our bullet so that it will fly in a direction that we shoot it in, let's consider the bullet itself. Well, for our purposes, we have this bullet that will be a single bullet that will just fly, hit something and disappear. Again, we would like to have a specific data object that will store all the information about our bullet. So let's go to our scripts folder, the data SO, let's right click here, create, and let's create a C# script. Let's call it bullet data SO. Okay, let's open it up in Visual Studio. Great. Again, we are going to simply create a placeholder for us. So let's delete the start and update. Let's extend not mono behavior but scriptable object. And we are going to add an attribute here so we can create it from the inspector. We are going to create asset menu, open parentheses, type a menu. You should have a type menu name, and we are going to add quotation marks, and we are going to call here weapons slash, and let's call it bullet data. Now, if we have typed it correctly, we are going to only have one folder or a space in our inspector in the create menu for weapons for the bullet data and for the weapon data, since we want to keep it all in the same place. So let's save it and let's see if it works. Let's go back to Unity. Great. What we can do is right click here, create, and we can see weapons, and we have now bullet data and weapon data. Great. Now we can start creating our bullet. We will want to have a possibility to create multiple bullets or multiple bullet types. So what we are going to do is let's go to our scripts folder, our weapons, and let's right click and let's create a C# script. Let's call it bullet. And let's open it up in Visual Studio. Great. What we are going to do is we are going to create an abstract bullet class. So let's delete the start and update methods. Let's create public abstract class bullet that extends mono behavior. And what we are going to have here is we are going to create prop tab bullet data SO, and we are going to call this using tab move to the name, and let's call it bullet data. Again, what we can do here is add an attribute field, and let's add a colon and serialized field. And this will be an abstract bullet class that we will use. And what is important for us is that we give it the bullet data SO. So this class and the deriving classes from it will say to the bullet how it will act, but the data for the bullet will be stored in our weapon. So if we have a gun, it will maybe change, we will maybe able to change bullets in it, or we are going to create a couple of guns that shoot in the same fashion but have different bullets. So this gives us a lot of possibilities, because of course we could assign to different bullets. In the next video we are going to create a specific bullet, meaning the regular bullet. It will simply fly into the direction that we have shot it, and it will simply be destroyed on collision. So let's implement a regular bullet script in the next video. In the previous lecture we have talked a bit about the physics layers, and unfortunately I have forgotten to include an important step, so if you now play the game we will be able to go out of our bounds of our room. So that's not good. So what we will want to do is, let's stop the game, go to the hierarchy and choose our map, open it up, choose our collisions tile map, and make sure that it is on a layer called obstacles or obstacle. Great. Now, since we know that our player have this movement collider which is tagged as the player movement collider, and the enemy will have appropriate enemy movement collider, we will want to go to our edit in the top menu, project settings, and I have it docked here, and we are going to go to our physics 2D, and I have forgotten to include this collision between those two layers, so make sure that your player movement collider and enemy movement collider is colliding with the layer obstacle. Now, if we press play, we should be able to still collide with our map, so this should be fixed now. And it is. Okay, great, let's continue with our main topic of this lecture. In the previous video, we have talked a bit about the physics and about the bullet component, that we will need an additional data file, that we have created the blueprint in our scripts in our data, which is bullet data SO, and we have added to our weapons folder our bullet abstract class. Now what we want to do is just create a regular bullet script that will drive this bullet prefab that we have created. So let's right click here in the scripts folder, in the weapons folder, right click, create, and let's create a C# script. Let's call it regular bullet. And let's open this script up in Visual Studio. Great. What we want to do is, let's for now delete the update and start methods, and we are not going to extend the mono behavior, rather we are going to extend from the abstract class bullet, because now this will give us the access to the bullet data SO. Let's go back to our regular bullet class, and what we will need to do here, first we will need to get the reference to our rigid body. So let's type protected rigid body 2D. Let's call it rigid body 2D. Great. And now we are adding those protected keywords here, and not without a reason, because when you want to use the same logic, you might want to extend this regular bullet and modify its parameters or add some custom methods. So this might be useful. And I have forgotten to add one thing to our bullet script, so right click on it and you can click go to definition. And what I want to set is our property. I want to add virtual keyword to it. So this will mean that we can modify how our bullet data behaves. Now, if for some reason this field attribute doesn't work for you in the project, this is pretty important to recreate this. And we are going to comment this using Ctrl-K, Ctrl-C by selecting it. And let's create prop full snippet, tab twice, and now we have created a backing field together with a property. What we want to do is we want to make sure that this private int myvar is instead of type bullet data SO, so type bullet data SO. Let's change the name to be bullet data with lower b. Tab again to move to the name of this property, and we are going to call it bullet data as we did previously. Enter. And now we want to add to it virtual to the property keyword, and we want to also make this bullet data as a protected value. Okay, and we can add to it serialized field, and now we should be able to expose this in the editor, so we can assign to it the bullet data and we will be able to set it through the script using this bullet data property. But hopefully this field colon serialized field attribute will work for you as well as it works for me. Let's go back to our regular bullet. I have it open in Visual Studio. Okay, and what we will want to do is we are going to type override, and we will be able to override the bullet data property. And now this gives us some opportunities. I'm going to format this a bit. Okay. And what I'm going to do is I'm going to modify the set. So I'm going to add 2 parentheses to our set method. And we are going to, in fact, set the base bullet data to value. But as well, we are going to call our rigid body 2D equals get component of type rigid body. So we need to go and we need to do this here because we will have a drag value in our bullet data. What I will want to do is make sure that I have the rigid body 2D, and I'm going to call rigid body.drag equals our bullet data dot friction. And we are going to alt enter on it, and we are going to choose generate property bullet.data so.friction in our data, and it will be of type float. So this will be important because if you want to create some kind of a shotgun bullet that is shot in many directions, so it is multi-bullet shot, but the bullets slow down and doesn't go very far, so maybe they are powerful, but they slow down and fall on the ground and disappear. And if we have a drag on our rigid body 2D, we can create such an effect. So this is why I want it here, because if we are going to implement our shotgun, we will need to have this drag, and we are going to create very powerful but with low range bullets. Next, what we are going to do is we are going to create fixed update. So type fixed and choose the fixed update. And do remember that if we are playing with rigid body 2D, we want to set it mostly in our fixed update. And since our bullet, or rather our rigid body 2D added to the bullet, is kinematic, we are going to not use the velocity but rather the move position method. So in our fixed update, we are going to check if our rigid body 2D is not null, and we are going to check if our bullet data is not null, because our bullet data contains all the logic behind how our bullet should act. We are going to call our rigid body 2D dot move position, which is meant to move rigid bodies that are of type kinematic, and we are going to call transform dot position, so the current position of the bullet, plus we are going to call bullet data dot bullet speed times transform dot right, and we are going to calculate times time dot fixed delta time. We do not have this bullet speed, so let's alt enter on it, and it will want to generate as a vector 3. Now this isn't good, so let's click it, generate property, and let's right click on it and go to the definition, and instead we are going to change the type to be float. So this will be our bullet speed. So let's go back to our regular bullet. You should have it opened here in Visual Studio. Great. So now we have moved our rigid body, so our bullet, and it is constantly flying in the direction that it is facing. So what we will need to do is simply spawn our bullet in the correct direction. So the bullet is facing the correct direction that we want to shoot, and this will do the rest. Okay? For now it is enough code, but we still do not have our bullet data set. So in the next video, we are going to tweak our bullet data, and we are going to test if our bullets actually fly in the direction that we point them to fly. So let's save our script. Let's go back to Unity. Okay, great. Let's assign to our bullet our regular bullet script. Great. Let's choose in the inspector the override drop-down list. You can see that we have added this, so let's apply all changes. So all the prefabs has this regular bullet script, and I will see you in the next video. In the previous video, we have implemented the regular bullet script, I think it is in weapons, regular bullet. And I said that we will need to fix the bullet data SO so that we can start shooting. So let's go to our scripts folder, to the data SO, and let's open up the bullet data SO. Great. We are in the bullet data SO script. This is a scriptable object that we have created a while ago. And we have created already here two parameters, friction and bullet speed. We will need to add here a couple of more fields so that we can spawn properly our bullets and make them fly in a way that we want them to fly. We will create above our friction parameter property, we are going to create prop, tab twice, type game object, tab again to move to the name, and let's call it bullet prefab. Again, we are going to add a field attribute colon serialized field, and now we should be able to see it in the inspector. Next, let's add the same parameter to our bullet speed, and for the bullet speed we can add again the range. So let's add field attribute colon and let's add range, and let's set it to be 1 as the minimum range and 100 as the maximum range, and let's set it to be 1 by default. Great. Let's maybe move it above the friction, since the friction is less important than the bullet speed. Next, again above the friction, since the friction is least important of all of those parameters, we are going to create a prop, tab twice. We are going to create an int value, and we are going to tab to move to the name and name it damage. Enter, and let's copy this serialized field and maybe even the range attribute and paste it here as well, and let's set it range from 1 to 10. So this is the damage value. Next, we can have our friction, so let's add to the friction again the serialized field, and maybe let's set for the damage the default value to be 1. Okay, now for the friction I am not yet sure what should be the value of the range, so let's add the range from 0.1f up to 100, for example. Okay, let's save it. Next, we are going to create a parameter of type bool, so prop, tab, bool type, tab to move to the name, and let's call it bounce. So the idea is, maybe we want them to hit a wall and bounce back as a ricochet. So for this, we would have this flag checked, and then we would know if we would like this kind of bullet, or do we have no bounce and the bullet just gets destroyed when it hits an obstacle. Again, let's copy the attribute field, serialized field, and it will be exposed in the inspector. Great. Now, again, another thing that we may want to have in our bullet is that it goes through the enemy. So for example, we may want to have some kind of arrows that go through multiple enemies in a straight line. So for this, we are going to create another prop, tab, bool type, tab to move the name, and let's call it go through hittable. And hittable will be the name of our interface that we'll implement soon, so that we can hit our enemies and whatever needs to get hit. Okay, let's copy the field attribute here as well, so we can expose it. And one more type of bullets that we may want to have is a raycast. So instead of shooting a bullet, maybe we want to raycast some kind of laser and just spawn particles. So we are going to create another prop, bool, tab to move the name, and is raycast. Okay, and again let's copy the field, serialized field attribute, and let's paste it above this is raycast. Great. Now, what else do we need? Well, we will soon need to have a knockback added to our enemies, as well as we are going to have impact particles or impact prefabs spawned when we hit the enemy or hit the obstacle. So what we are going to do is, let's prepare for it. Let's create prop, tab, game object, move to the name with tab, and call it impact obstacle prefab. And we are going to only spawn one type of prefab when we hit an obstacle. And let's copy this, let's paste it below and change it to impact enemy prefab. Okay, again we will need to add those two attributes, field, serialized field, to both of those game objects. And next, what we can do is we can create a knockback. So we will want to have different bullet of different strength, so it will deal damage, but at the same time maybe we want to have some bullets that push enemies really far. So maybe a shotgun will push enemies really far, while assault rifle will shoot multiple bullets in the same time that you shoot a shotgun. So if we hit an enemy with a shotgun bullet, the enemy will fly away much further, so we have some time to reload our shotgun. So let's create prop, tab tab, float, tab tab, and let's call it knockback power. Enter. And let's copy this, paste it below, and we are going to change the name to be knockback time. So this will be maybe time or delay. So this will be the delay because we will need to stop at some point the force that pushes enemies backwards. So this will be the delay after which the enemy will be back to move and attack our player. And we are going to add again this field colon serialized field, and let's create another attribute field colon, and we are going to call range. And let's add to our power 1 to 20 as the range. Let's copy both of those attributes and let's paste them above the knockback delay, and instead our delay will be from 0.01 f up to 1 f, since 1 second of a knockback is a really long time, so we do not want to exceed it. Great, now our bullet data SO is ready, so we can set up some data here and we can give it to our assault rifle and test how our bullets will affect our enemies. Great, so this is it for our bullet data SO. Let's go back to Unity. Okay. We have implemented a lot of fields to our bullet data SO, so let's now go to our assets folder in the project section. Let's go to our underscore data, to the weapon data, and we will want to create a new folder. So let's right click, create folder, let's call it bullet data. So we can separate weapon data from the bullet data, but still store it in one folder. Let's right click here inside this bullet data folder, create our weapons, and we have bullet data scriptable object. And let's call it regular bullet. Okay. We have our bullet game object in our scene view. We can currently delete it, since if you have any overrides, make sure you apply it, and we can delete this prefab. What we can do is go to our regular bullet data, our bullet data SO, and we are going to start filling it in. So let's choose the bullet prefab, and we are going to choose it and set our bullet as the bullet prefab. Next, the speed, let's set it to something like 30. Of course, we are going to be able to test it very soon, so let's set some values and let's have them prepared. Damage will be 1. We are going to not have bouncingness since we have no logic for it to work for now. The damage will be 1, the friction will be 0. It will not go through the enemies, it will not be a raycast. We currently do not have obstacles, but we can set some knockback parameters. So let's set the power to be 6, and let's set the knockback time to be 0.1. And what we can do is reopen quickly the bullet data SO by clicking here, and let's set the default parameters, something like knockback power equals 5 and knockback delay equals 0.1 f, just to have those parameters as the default values. For the game objects we cannot really set them, and for the bool values they will be set by default, so this shouldn't be a problem, but we can of course set the raycast to false. And let's copy this, let's paste it to the go through hittable, to the bounciness, and the friction we can set it to be 0. And we have, for some reason, the range is from 0, 1 to 100, so let's set it from 0 to 100 for the friction. Okay, and now we can set the friction to be 0, and it all should work. So let's save it, let's go back to Unity. Great, and I have some issue here, so I'm going to double tap on it. I didn't finish this line. So I'm going to add semicolon at the end, save it, go back to Unity. Great. Now the error is gone. And in the next video, we are going to use this data from our bullet data SO to make our bullet fly through our shooting mechanic of our gun, so through our weapon script. So this is what we are going to do. We are going to enable us to shoot our weapon by clicking a button, a left mouse button. So see you in the next video. In the previous video, we have created some data or some content for our bullet data SO script. Now we would like to use this. So first of all, what we will need to do is add the bullet data SO reference into our weapon data SO. So let's go in our project section to the scripts, data SO, and let's open our weapon data SO. Great. What we are going to do is we are going to create at the top of this script a prop, tap twice. Let's type bullet data SO, and this will be the reference to the bullet that our weapon can shoot. We're going to type bullet data as the name. Okay, enter. And let's add the field, colon serialized field attribute to it to expose it in the inspector. And now we should be able to get the reference to the bullet data from our weapon data. Thus, we will be able to place this bullet data into our bullet prefab that will spawn. So let's go back to Unity. Great. Let's go to our project section to underscore data, weapon data, choose the assault rifle weapon data, and in space where there is bullet data, let's click this cog icon and let's select our regular bullet. Great. Let's save our Unity editor, Ctrl S. Now, what we will need to do is let's go to our underscore scripts folder, to our weapons folder, and let's open our weapon script, since this is responsible for actually projecting the bullet, and we are going to add this code into the script. So let's open up this script. Great. We have a lot of code here already created, and what we will want to do now is we are going to slide it down to where our shoot bullet is. If you can't find it, you have this useful drop-down list in the top right corner of the code editor, and you can see all the methods and all the fields, and we can choose the shoot bullet method, and we should be transported to this method where it is in our code editor. What we are going to do is let's delete this log statement, and we are going to call a method called spawn bullet. We are going to pass here our muzzle dot transform dot position. Great. And we are going to pass here again a calculate angle, and we are going to pass to this new method a muzzle. Okay, a lot of new methods, so let's finish this line. Now let's create this calculate angle, alt enter, and generate this method. And what we will need to do is, first of all, we are going to change the return type of this calculate angle, and we are going to want to return a quaternion, which represents the rotation. And now, if we alt enter on the spawn bullet and generate this method, it will be generated and it will take appropriate quaternion value as the input parameter. So now, what is the calculate angle? Well, if we have a spread for our weapon, then we would like to calculate the angle at which we should spawn our bullet, because we know that we want to spawn it to face the direction of our weapon. But if we want to add a spread, we are going to add at this point some random angle to this rotation, so we can spawn it so it flies in a different direction than straight ahead in the direction that our bullet is facing, that our weapon is facing, so that we have more realistic weapon behavior. So what we can do now is we can calculate the angle by, first, let's delete this throw statement, and we are going to type float spread equals, and we are going to call random. We're going to calculate random range. Okay, and we have some issue, so let's alt enter on this random, and we can see that we have our system.random and Unity engine.random. So there is a collision between libraries, and what we can do is let's select this using random at the bottom equals Unity engine.random. this statement will be added at the top of our file. So we are going to import the Unity engine.random library when we are calling the random. And we are going to slide down back to our calculate angle. Now we should have our range, open parentheses, and it all works. And we are going to call our weapon data.spread angle. And we are going to pass minus at the start of this. So we are going to calculate from minus weapon.spread angle to weapon.spread angle. So we are going to rotate it by a small degree to the left or to the right. Now, we have the spread calculated. We can calculate the quaternion bullet spread rotation equals, and we are going to call quaternion, and we are going to convert this from Euler angle. So this is an angle in Euler values. We are going to calculate the quaternion from this angle, and we are going to pass a new vector 3, 0 on x, 0 on y, and we are going to pass spread on z value, since we are going to only rotate our sprites on the z axis. And what we want to return here is the angle at which we should spawn our object. So we need to include the rotation of our muzzle, because we are representing our gun as a muzzle, and the muzzle is facing the same right direction as our gun. We made sure of it about it in the inspector. So what we want to return is let's type return, and we are going to calculate muzzle.transform.rotation, which is the rotation of our muzzle, and we are going to multiply it. So basically add two rotations. So we are going to add the spread angle, and to add two quaternions we will need to multiply them. So we are going to multiply it by the bullet spread rotation. Great, and now we have our rotation calculated. So all is left is to spawn the bullet. And this will be pretty simple. We are going to delete this throw statement, and what we are going to call here is var bullet prefab equals our instantiate. So we're going to create this, the instance of a bullet, and we are going to pass here our weapon data dot bullet data dot bullet prefab. Great. We are going to add to this position. So the position will be the position of our muzzle that we have passed in the shot bullet, and we are going to pass it here the angle, which is the quaternion. So let's rename the quaternion to quaternion angle, or maybe rotation. So we have position and rotation, and we are going to pass the position and rotation to the instantiate function. And what we will want to do is we are going to call bullet prefab dot get component, and we are going to get the component of type bullet. And let's finish the statement, and I'm going to explain why it is so useful to create an abstract method such as this. And we are going to call here bullet data, which is our property, equals our weapon data dot bullet data. So now what this line does is, if we right click on the bullet and go to the definition, you might remember that we have created this bullet data property. I have explained why if your field colon serialized field doesn't work, we can create it like this, and this is the basic way to create a property and a backing field. But what it does is we have our bullet, and our regular bullet, let me find it in the inspector, here it is overriding this bullet data as a bullet data property. So whenever we call on our bullet data equals something, we are going to call this method if our bullet prefab has the regular bullet on it. And this in turn will not only assign the bullet data, but also get the rigid body and set the drag value to the friction from our bullet data. So this is the power of inheritance, and that's why we have created the abstract bullet class, so we can use it and set up the bullet data, and then create some custom regular bullet or custom bullet classes that contain the logic behind how to move our bullet and what it should do, based on this bullet data that we pass to it. Great! So with this small digression about the coding and programming in Unity, let's go back to Unity. And now, if we press play, because everything should be set up, we have our player. Our player has assault rifle, which has a weapon script on it. Weapon script has assigned weapon data, and weapon data from our underscore data has its data assigned and we have our, no, this is player movement data, we have our weapon data, and it has assigned the bullet data to it. So we have created this pretty complex structure, but now if we want to create a new weapon, we simply create a new data, assign to it new bullet data, and we simply assign it to our weapon. And now we can press play, and let's see. Now we should be able to click, and our bullets are flying. And the best part is that we can go to our assault rifle, increase the spread angle maybe to 10, and let's see how those bullets are flying. Now you can see at the end, so in the corner, that bullets are flying with a bigger spread. And now what we can do is let's decrease the spread, let's increase the weapon delay to something like 1, and now we can hold our fire button, and we can see that the bullets are flying a lot slower. And what we can do as well is to call the multi-shot, choose the bullet count to 5, and we can see that those bullets are flying and are spreading. So let's increase the spread to something like 10, and we have our shotgun already prepared for us. So we can see that it gives us a lot of possibilities. Our ammo has run out, so we have 0 ammo, that's why we cannot shoot anymore. But basically you can already see that we have all of those possibilities at our disposal, and now we are also spawning our bullets and shooting. But of course there is one issue. Our bullets are still spawned in our scene, so we have about 100 bullets, and this is no good. So we will need to implement in the next video a way so that the bullet will be destroyed when they collide with our obstacle layer. So see you in the next video. In the previous lecture, we have implemented a logic to shoot our bullets, and we have tweaked a bit our assault rifle, so make sure you get it back to the previous setting. So it was automatic fire with spread equals 3, we had the weapon delay of something like 0.1, and we had the multiple shot disabled. If we press play, we should now be able to shoot our bullets, and we can see in the scene view that unfortunately all our bullets are flying over the walls, and we do not want that. We want them to hit the wall, and we want them to be destroyed, because now they are infesting our hierarchy, and in this situation we would surely run out of memory if we keep spawning all those bullets and never destroy them. So let's stop the game, and what we are going to do is we will want to go to our scripts folder. Let's open up the weapons folder, and we will want to open up our regular bullet script. Great. Now since we have our collider applied to the script, we can create underneath all of those methods in the regular bullet script on collision enter. Make sure that it is 2D, because we are working in 2D space, and let's simply debug.log our collision.name. I think we need to have the game object reference, and now we can print the name. Okay, and now what we can do is let's go back to Unity. Okay, now if we press play, let's see what happens. Let's shoot some bullets, and exactly nothing happens. So why is that? We are going to take a look at the colliders documentation, or rather Unity manual, and in documentation we can see that the colliders have something at the bottom called collision action matrix. And what we have here is what are the interactions between different setups. Our tile map called collider or collisions has a static rigid body on it and a collider, and it can interact only with a rigid body collider. So this is the only interaction that a static collider might have. So all it means is that if we call on collision enter, exit or stay, it will not be triggered. For a kinematic rigid body collider, which is our bullet. But we can have a trigger message that is sent to our bullet if we set our static collider to be colliding or triggering an event with a rigid body trigger collider or kinematic rigid body trigger collider. We need to make our bullet into a trigger, and then we can listen for a trigger message between our static collider or our rigid body collider, so between our tilemap colliders and between our enemies or player. And that is what we will need to do. We will need to set our bullet to be trigger, and we will need to listen for on trigger enter 2D. And if you want to find it, you need to type Unity manual and colliders, and you should find this website that contains this table. Great, let's go back to Unity. Okay, so what we will want to do is choose our bullet inside our prefabs and make sure that the capsule collider 2D is set to be a trigger, so isTrigger is set to be true. Now we will need to go back to our scripts folder, to our weapons, and let's reopen our regular bullet script. Great! Now we should have our on collision enter that didn't work. Let's delete it, and in its place let's create on trigger enter 2D. And now let's type debug.log, and we are going to call collisions, or rather collision, so the parameter passed to this method, .gameObject.name, and let's confirm that we can detect those triggers. So let's go back to Unity. Okay, I'm going to restart the game, and let's see if we now shoot our bullet. You can see that there is a message, and we are calling the collisions. So the collisions is the name of our tilemap, which indeed it is, collisions. And now we can see that all of those messages are being printed, so all the bullets are colliding with our obstacle. So let's go back to our scripts. The regular bullet. Great. So let's create a private void. Let's call this hit obstacle. Okay. And what we are going to do is let's debug.log here, and we are going to log simply hitting obstacle. Great. And what we can do here is we can detect in our on trigger enter what exactly did we collide with. So we are going to call if our collision, which is the parameter that our on trigger enter 2D receives, .gameObject.layer, and this is what I was talking about. We can detect what type of layer we have collided with. So we can type layer mask, name to layer, and we can type here our name of the layer we have created. So I happen to know we have obstacle with capital O, but we can create the data about the layers inside our regular bullet, for example, and then just use those layers names from the parameter that we input through the inspector. For now, we are going to leave it like this, and we can call this hit obstacle when we are colliding with an obstacle. And at the end, what we will want to do always is destroy, and we are going to pass here game object, which means we want to destroy this concrete game object. Let's save it. Let's go back to Unity. I'm going to restart the game, and we will see if our bullet gets destroyed. Okay, let's press play and let's see. If we are going to shoot, our bullets are now being destroyed whenever we hit our colliders. And let's clear it and let's shoot one time, and we can see that we are hitting an obstacle, so everything works. If it doesn't work for you for some reason, take a look at the map, at the collisions. What is the name of the layer? In my case it is obstacle with capital O, and make sure that you type it correctly in your script. Great! Now, to be honest, the lack of sounds is killing me, so in the next video we are going to implement some nice sound to be played when we are firing our weapon, and a sound of a gun with no bullets in it. So we are going to do this in the next video. See you there! In the previous video, we have enabled a possibility to destroy the bullets when we hit an obstacle, and we are discovering what exactly did we hit, and in this case we have only obstacles, so that's what we are printing. Now, we would like to add some sounds to our game, because it is pretty stupid that we can walk and we hear our player walking, but if we are shooting, nothing happens. So let's stop the game, and I believe we have in our scripts folder a audio script that we have implemented for our player, and let's find it. And I believe this is the agent step audio player. Let's open the script up. Great. Now, I have mentioned to you previously that we wanted to create an abstract class from it. So what we are going to do is we are going to select the methods beside the... actually, we can copy the whole file. So let's copy all those methods and properties. Ctrl-C. Let's go back to Unity. Great. Let's right-click here in the scripts folder, create, and let's create a C# script. Let's call it audio player. And let's open this script up in Visual Studio. Okay. We would like to make it into an abstract class so we can use this audio player functionality for other audio players, such as we are going to implement for our weapon in a bit. So let's make it an abstract class, audio player, and it inherits from MonoBehavior. And instead of update and start, we are going to paste what we have copied. Now, starting from the end, but because probably you are here as well, let's delete the play step sound, since this is very not universal for us. We have play clip, we have play clip with variable pitch, we have our start and our awake. We do not need to have an audio clip step clip because we have no use for it. And that will be it. This will be our audio player. Let's copy the name. And now let's go back to Unity. Great. We are going to reopen our agent step audio player. Okay. And what we can do here is we can paste, instead of the MonoBehavior, we are going to paste the audio player. I have forgotten to cut out this require component, since we can attach it to audio player as well. We are going to do it in a bit. What we can do is delete the fields audio source, float pitch, and float bass pitch, because we have those in our audio player. We can delete the awake and start methods, since we don't need to have them here. We can delete the play clip and play clip with variable pitch methods, since we have those in our audio player already. So now all is left is our player step sound, which can call our player clip with variable pitch from our audio player. One last thing that I have forgotten to do is to cut out this require component attribute from the agent step audio player. Let's save the script. Let's right click on our audio player and let's go to the definition and let's paste our attribute above the abstract class audio player. So any class derived from the audio player will inherit this attribute as well and will require a game object to have an audio source on it. Great. Again, let's go back to Unity. And now we can go to our weapons folder, right click, create, and we are going to create a new C# script called weapon audio. Let's open up this script in Visual Studio. Great. Now we are going to delete the update and start, and we are going to call in our weapon audio, and we are going to inherit from the audio player. Yep. And we have our class, and what we will need to add here is serialized field attribute. Let's create private audio clip, and we are going to create two clips. First one will be shoot bullet clip. Let's set it to be null by default, comma, and we are going to create out of bullets clip. And let's set it to be null by default. And setting those to be null will allow us to avoid the warnings inside Unity, because it will want to inform us that those are never assigned. Okay, and what we are going to create here is public void play shoot sound. And this method will simply call play clip from our audio player parent class, and we are going to pass our shoot bullet clip. Let's copy this method and paste it below, and we are going to rename it to play, I have misspelled it, so play out of bullets shot or no bullets sound, and we are going to simply change the clip from shoot bullet clip to out of bullet clip. And this will be it for our audio for our weapon. Now let's go back to Unity. Great. Now we are going to go to our hierarchy, open the weapon parent, assault rifle, expand it, right click on it, create an empty object, Make sure that this is inside our assault rifle, and let's rename it to our weapon audio. Okay, I have misspelled it. Now, we are going to drag onto this new game object. Hopefully it has transformed with position 0. If not, please reset it. And we are going to drag here our weapon audio. And you can see that it has already added to us to this game object audio source, which is great. And we have our weapon audio script. What we can do is, let's first focus on our weapon audio script. Let's choose our shoot bullet clip. I'm going to choose, and I'm going to search for machine. And I'm going to choose machine gun 1. And for the out of bullet clip, we are going to click here on this cog and type no, and we should have no ammo. Okay. And we will want to set the audio source that we also added here. For starters, we will want to uncheck the play on awake, since we do not want to play on awake. We may want to decrease the volume to 0.5. We should create an audio mixer and add all those audio sources to an audio mixer, but we are going to leave it as is because this isn't the main focus of this course. And now we should be able to play the sound. Make sure that your spatial blend is on 2D because this is a 2D game, so we do not care about 3D sounds. And what we are going to do is we are going to assign those two methods inside our weapon audio. Now, I have mentioned before that there was a reason for using these Unity events. So let's go to our web assault rifle. And here we have exposed two Unity events in the previous video. Inside our weapon script, there should be on shoot event and on shoot no ammo event. And how easy it is to add audio feedback is just to create a listener here on shoot, for example. Drag our audio, weapon audio game object here. Choose a function, choose weapon audio, and choose play shoot sound. And for on shoot no ammo, again do the same. Drag here a weapon audio and choose a different method. That one is called play no bullet sound. Now let's press play and let's see if it all works. So now, and again here, our shooting sound is being played. Great. And what we can do is let's choose our weapon. I think it was assault weapon. Let's decrease the ammo through the ammo parameter to be something like 10. And now try shooting. And now you can hear that the no ammo sound is only played once. And it doesn't continue due to our logic that simply stops us from shooting even though we are holding our button to shoot. Great! We have some audio feedback. It sounds quite good. And we have this all working just by dragging the concrete method into our events. And you can already see that we have a lot of possibilities to add any other kind of feedback to our weapon on shoot, like a muzzle flash, by simply creating a light here where our muzzle is and turning it on and off if we want to create this muzzle flash effect. Now, I believe that this is enough for our shooting system for now. And we should focus our attention on creating our enemies before we start adding some screen shake and some effects to add some details to our systems to make it more fun to watch and fun to play. So maybe let's focus on creating an enemy in the next section. You can play around with the settings for your bullets or create other assets and try them out and see what you can achieve with the current system. And in the next video, we are going to start creating our enemy. So see you there. And one last thing that we didn't add to our game was the crosshair. And of course, we have a crosshair in our sprites folder. So let's search for sprites. Let's type cross. And we have our crosshair red small. While it is perfectly alright to keep it as a sprite, we have another setup here, and this is cursor. Let's apply it, and now what we can do is let's quickly go to our scripts folder, and let's create a new C# script. Let's call it Game Manager. Okay, let's open it up. Great. Let's delete the content of this class. It will be in mono behavior. Let's create a serialized field and we are going to create private texture 2D, and we are going to call it cursor texture equals null. Okay, this will be our crosshair texture. Now we want to set it up, so let's create start method, and we are going to call here set cursor icon. Okay, we do not have this method, so Alt Enter and generate it. And in this method, we are going to implement the logic behind setting the cursor in the correct position. So Unity provides us with a cursor class, and it seems I have misspelled my naming, so I'm going to fix it. Great. So now it is correct, and we can use this class to set the mouse pointer to whatever icon do we wish it to be. So we are going to call set cursor, and we are going to pass here our cursor texture because it is texture 2D, and we can pass here the hotspot, which means where should the middle of our cursor be depending on our image. We are going to create a new vector2, and we are going to pass here a cursor texture dot width divided by 2f, since we want to just place it in the center of this image that we have for our cursor. And we are going to call cursor texture dot height divided by 2f if you have an unequal size of your cursor. Okay, great. And the last parameter is cursor mode, so we are going to call cursor mode dot, and we have auto or force software, and we are going to choose the auto. Great. Let's save it. Now let's go back to Unity. Okay, let's create a new game object in our hierarchy. Let's call it game manager. I can already see that the transform is not in the 000 position, so I'm going to use those 3 dots and reset it. Let's assign our game manager script onto our game manager game object, and again let's choose sprites. Let's type cursor or crosshair, I think. Crosshair. Let's assign it to the texture, and now if we press play, we should see that our cursor is changed into a crosshair, and now we can use it to shoot in its direction. Great! So I think this was the last step for our shooting system to finally be somewhat complete. So let's go to the next section when we are going to start implementing the enemies. See you there.